A shallow earthquake beneath western Naples did more than rattle windows on July 31. It knocked out power, interrupted rail and metro service, damaged buildings, and sent people into the streets. The magnitude was 4.7, the depth was only about 3 kilometers. And the ground that moved was not sitting on an ordinary fault system. It was moving inside Campi Flegrei, the Phlegraean Fields, a vast volcanic caldera that overlaps some of the most densely populated parts of the Naples metropolitan area. That is where this story becomes different from the volcano most Americans instinctively think about. Yellowstone is enormous, famous, and capable of producing volcanic and hydrothermal hazards. But in the U.S. Geological Survey's August update, Yellowstone was at normal, with background seismicity and deformation. Campi Flegrei, by contrast, is officially at yellow alert in Italy, classified as a state of medium unrest. Those two alert systems are not identical, so this is not a one-to-one ranking, but the difference in present behavior is impossible to ignore. Campi Flegrei is actively deforming. It is producing frequent shallow earthquakes. Its gas and fumarole system is closely monitored. And about 500,000 people live inside the official volcanic red zone, the area where Italy's Civil Protection Department says preventive evacuation would be the only protective measure if authorities declared an alarm. That does not mean 500,000 people are about to be evacuated. It means the urban geography of this volcano is extraordinary. The caldera does not rise above the skyline as a single cone. There is no perfect mountain silhouette marking the center of danger. The volcanic system sprawls beneath towns, roads, neighborhoods, rail lines, coastal districts, and parts of Naples itself. People do not merely live near a volcano in the familiar sense. They live across a volcanic landscape whose most important boundaries are drawn on emergency planning maps rather than against the horizon. If you want clear, evidence-based updates on hazards like this without turning uncertainty into a fake prediction, subscribe. Campi Flegrei is exactly the kind of system where the difference between what is measured and what is imagined matters. Since 2005, the ground in the Phlegraean Fields has been rising again. Italy's Civil Protection Department says total uplift has exceeded 150 centimeters, while seismic activity has intensified, especially since 2023. In May 2026, a magnitude 4.4 earthquake triggered regional civil protection activation. Then, on July 31, the magnitude 4.7 shock struck at shallow depth and produced real disruptions. That sequence is why the word restless matters. But it still does not mean eruption. Campi Flegrei is going through bradisism, a long-term pattern in which the ground rises and falls as pressure and fluids change beneath the caldera. Bradisism can stretch the crust, activate faults, and generate damaging shallow earthquakes even without magma reaching the surface. The Civil Protection Department describes the current state as medium unrest, not pre-alarm and not alarm. This distinction is the first major key to the story. The visible danger right now is not a giant eruption column. It is the slow deformation of a heavily urbanized caldera and the earthquakes produced as that deformation changes stress in shallow rock. That makes Campi Flegrei a strange kind of volcanic threat. Its present hazard can be serious before an eruption begins, and it can remain serious even if an eruption never begins at all. To understand why, picture the ground around Pozzuoli not as a rigid plate but as the roof of a complex pressure system. Beneath it are rocks, fractured by thousands of years of volcanic activity, hot fluids, gas, and deeper magmatic processes whose exact roles are still being studied. As pressure changes, the surface can rise. As the crust is strained, earthquakes can occur, because many of those earthquakes are shallow. Even moderate magnitudes can feel violent in dense urban neighborhoods. The July 31 event made that physical reality visible. A magnitude 4.7 would not normally dominate global earthquake news. Here, depth and location change the meaning of the number. And location is where the comparison with Yellowstone breaks open. Yellowstone's current monitoring status is background. Campi Flegrei is in sustained unrest under a yellow alert. More importantly, the Italian caldera is embedded in a major metropolitan environment. The red zone includes Pozzuoli, Boccoli, Monte di Procida, Quarto, portions of other municipalities, and several neighborhoods of Naples. This is not a remote supervolcano story. It is a city built across an active caldera. There is another reason Campi Flegrei can hide in plain sight. A caldera is not a mountain in the usual sense. It is a broad depression created when the ground collapses after large eruptions remove material from below. At Campi Flegrei, that depression has been reshaped by later eruptions, erosion, urban construction, the coastline, and the Gulf of Pozzuoli. Ancient vents and craters are scattered across the landscape rather than concentrated at one summit. That means a person can drive through the volcanic system without ever seeing a single object that looks like the volcano. Solfatara, Pisciarelli Lake Averno, Monte Nuovo, the neighborhoods around Pozzuoli, and parts of western Naples are pieces of one much larger volcanic field. The absence of a towering cone can make the hazard feel abstract until the ground itself starts moving. And the ground movement is not just a technical detail recorded in a laboratory, it is the defining physical signal of the current crisis. Bradyseism changes elevation slowly enough that no one watches the city rise in real time, but geodetic instruments can trace the cumulative movement. Over years, that movement adds up. It changes stress in rock, and the resulting earthquakes can arrive in bursts that are felt immediately by people living above them. That is why the present story starts with a moderate earthquake rather than an eruption. The quake is not proof that magma is breaking through. It is evidence that the crust is under active stress inside a volcanic system already being watched at an elevated alert level. The easiest mistake is to hear the words caldera, Yellowstone, and 500,000 people, then jump straight to the largest eruption imaginable. That is exactly the interpretation the science does not support. Campi Flegrei has produced enormous eruptions in its geologic past. The Civil Protection Department describes the Campanian ignimbrite event about 39,000 years ago as the most violent eruption in the Mediterranean area, with an estimated magma volume of roughly 100 to 150 cubic kilometers. Another major event, the Neapolitan Yellow Tuff eruption about 15,000 years ago, involved roughly 20 to 30 cubic kilometers of magma. Those numbers explain why this place has a reputation. They do not tell us what happens next. Over the past 15,000 years, the system has produced more than 70 eruptions of different sizes. The most recent occurred in 1538, after about 3,000 years without an eruption. That event formed Monte Nuovo, a new volcanic cone, after a dramatic period of uplift. Historical evidence matters because it proves Campi Flegrei is not an extinct scar, but history must not be converted into a countdown. The modern crisis is dominated by Bradyseism. The current uplift phase began in 2005. The ground has risen by more than 1.5 meters in the long-term reference area. Earthquake activity has increased. Fumaroles and gas chemistry are monitored continuously. Italy raised the alert level from green to yellow in 2012 and under a 2025 update. The volcano remains classified at yellow with medium unrest and strengthened monitoring. That status is serious, but it is not a declaration that magma is about to break the surface. This is where the underground mechanism becomes more complicated than the headline. Scientists monitor seismicity, ground deformation, gas chemistry, and temperature because several processes can produce pressure changes in a caldera. Magma can release gases. Hot hydrothermal fluids can migrate through fractures. The crust can deform in response to changing pressure at depth. Faults can slip as the rock is stretched. These effects can interact, and the exact contribution of each process can change with time. In other words, the volcano does not send one simple signal. It sends a bundle of signals that must be interpreted together. A study presented by INGV in January 2026 explored a deliberately precautionary scenario in which the long-running uplift is driven by repeated magma intrusions at about 4 kilometers depth. Even under that assumption, the researchers concluded that current conditions were not suitable for an eruption. Their modeling suggested that a small magma reservoir and deformation of the surrounding crust could make it difficult for magma to maintain enough pressure to reach the surface. That conclusion is almost the opposite of the most dramatic version of this story. There may be magma involved in the long-term unrest, but that does not mean a pathway to eruption is open. The same study also explored what could happen if similar uplift dynamics persisted for decades. Under its assumptions, the system could eventually evolve toward conditions more favorable to eruption. But the researchers emphasized that the source of Bradyseism remains scientifically debated, and that those model results depend on assumptions that are difficult to verify directly. That is how volcanic forecasting actually works at a system like Campi Flegrei. Scientists build scenarios, compare them with observations, and update interpretations. They do not look at an uplift curve and read a date from it. INGV made that boundary especially explicit in May 2026 after media reports amplified a preliminary study about the future evolution of Bradyseism. The Institute said the research did not represent a deterministic forecast and did not predict imminent earthquakes or an imminent eruption. It warned that some media interpretations had attached claims to the study that were not present in the work itself. That clarification is important because Campi Flegrei is vulnerable to two opposite errors. The first is complacency, assuming nothing matters, because there has not been an eruption since 1538. The second is sensationalism, assuming every strong earthquake means the eruption has started. Both are wrong. The real story is more uncomfortable because it sits between them. A volcano can remain below an eruption threshold while still producing earthquakes strong enough to damage buildings, disrupt transportation, and frighten a large urban population. A caldera can be dangerous because of ongoing ground deformation and seismicity, even when the probability and timing of an eruption remain uncertain. The July 31 earthquake shows exactly why the middle ground matters. It caused outages, transit disruption, and minor structural damage. It was not an eruption, but it was also not meaningless background noise. The stress is being expressed through the crust, and the crust sits under a city. The past bradyseismic crises help show how dramatic that process can become without producing an eruption. During the major unrest episodes of 1970 to 1972 and 1982 to 1984, the Pozzuoli area experienced substantial uplift and thousands of earthquakes. Residents were moved from parts of the historic center. The ground eventually changed direction again, and no eruption followed. That history matters because it provides a real-world control case for the modern crisis. Strong deformation can continue for years. Earthquake swarms can intensify. Public disruption can become severe. None of those observations by themselves tells scientists whether the system will cross into eruption. At the same time, the current episode is not simply a replay of the early 1980s. The monitoring network is far denser, the urban exposure has evolved, and the present uplift phase has persisted for more than 2 decades. Scientists now combine continuous seismic stations, satellite and ground-based deformation measurements, gas chemistry, temperature observations, and other data streams to look for changes that might indicate a shift in the system. The pressure source is also not something that can be photographed directly. Researchers infer it from how the surface moves, where earthquakes cluster, what gases are emitted, and how those signals change together. That is why different scientific models can emphasize different combinations of magma, magmatic gases, and hydrothermal fluids without necessarily contradicting the observations. The uncertainty is about mechanism and evolution, not about whether the unrest exists. The unrest is measured. What remains uncertain is where it leads. Now consider what the official red zone actually means. It is not a circle drawn around a single vent. Campi Flegrei has no one central crater that emergency planners can treat as the only possible source. The Civil Protection Department notes that unlike a classic central volcano, eruptive vents could open across a broad area of the caldera. That uncertainty changes everything about planning. The red zone is designed around the hazard from pyroclastic flows, fast-moving mixtures of hot gas, ash, and volcanic fragments. If authorities declared the alarm phase, preventive evacuation would be the only protective measure for people in that zone. About 500,000 residents are included. Beyond it is a yellow zone with more than 800,000 residents where significant ash fallout could create additional risks. Those population figures are why Campi Flegrei can be a more immediate human risk story than Yellowstone, without needing to claim that it is a bigger volcano or that it would produce a larger eruption. The comparison is about exposure and current unrest. Yellowstone's August 1 update reported normal alert status, background seismicity, and deformation, 68 located earthquakes in July, and only minor caldera uplift since the beginning of the year. Campi Flegrei remains under yellow alert for medium unrest, with long-term uplift and intensified shallow seismicity. The monitoring systems and alert scales are different, so no scientific agency is publishing a formal Campi versus Yellowstone danger score. But one system is currently described as background. The other is not. And one of them lies directly inside a densely populated urban region where an emergency plan has to account for moving hundreds of thousands of people. This is the point where the title's fear needs to become practical understanding. A red zone does not mean an eruption is expected tomorrow. It means planners have already identified the area where the consequences of certain eruptive phenomena could be so severe that evacuation must happen before those phenomena begin. The plan exists because pyroclastic flows move too quickly and are too dangerous for evacuation after an eruption is underway. That is a very different kind of risk from watching lava advance slowly across an empty slope. At Campi Flegrei, timing would be everything. Authorities would have to interpret the volcano's monitoring data, decide when unrest had escalated enough to justify a higher operational phase, communicate that decision, and move people before conditions became too dangerous. Because the caldera is urbanized, roads, rail systems, schools, hospitals, neighborhoods, and coastal infrastructure are part of the hazard equation. The volcano is not separate from the city. It is underneath the city's daily systems. That is also why shallow earthquakes matter even when the volcanic alert level does not change. A magnitude around 4 or 5 at only a few kilometers depth can produce intense local shaking. Buildings that have already experienced repeated tremors can require inspection. Transport systems may be stopped as a precaution. Utilities can be disrupted. Residents can face repeated nights of uncertainty without any clear endpoint. This is not hypothetical. The July 31 magnitude 4.7 earthquake disrupted power and transportation and damaged some buildings. Earlier events in the ongoing crisis have also driven civil protection activity and public concern. Yet the official response has not been to declare that an eruption is imminent. Instead, the response has been more monitoring, vulnerability analysis, emergency planning, public information, and exercises. That tells you what scientists and authorities believe the current problem actually is: sustained unrest in a vulnerable place. There is another detail that makes this system difficult. The Phlegrean fields extend partly beneath the Gulf of Pozzuoli. The caldera's geography includes land and submerged areas, urban neighborhoods and hydrothermal zones, ancient craters, and modern infrastructure. Different parts of the system can respond differently as pressure and fluids move. That complexity is one reason monitoring must be multi-parametric. An earthquake catalog alone is not enough. Ground uplift alone is not enough. Gas measurements alone are not enough. A single research model is not enough. Scientists need the pattern. Are earthquakes becoming more frequent, stronger, shallower, or concentrated in new areas? Is uplift accelerating, slowing, or shifting spatially? Are fumarole gases changing in ways consistent with more magmatic input? Are temperatures changing? Are deformation and seismicity moving together or separating? Those questions matter more than any one dramatic reading. And even then, volcanic forecasting has limits. A caldera can change regime without erupting, pressure can migrate, fluid pathways can reorganize, earthquake swarms can intensify and then decline, uplift can continue for years, an eruption can remain physically possible without becoming the most likely immediate outcome. This uncertainty is not a weakness in the science. It is the condition the science is trying to measure. For 500,000 people inside the red zone, the purpose of monitoring is not to create certainty where none exists. It is to detect meaningful change early enough that decisions can still be made. Emergency planning also has to deal with a problem that is easy to underestimate from a map. People do not leave a metropolitan area as dots moving along perfect lines. Families may be separated when an alert changes. Some people will be at work, others at school, others in hospitals or care facilities. Roads can clog. Public transportation can be interrupted by the same earthquakes that trigger concern. Communications have to reach residents who speak different languages. Tourists who do not know the local plan and people who may already be frightened by rumors. Italy's planning therefore distinguishes scientific alert levels from operational phases. Yellow alert means increased attention and monitoring. It is not the same thing as an alarm order. Pre-alarm and alarm involve different civil protection actions, and the decision to move to those phases belongs to national authorities working with scientific assessments. That separation is essential. A seismologist can report that earthquake activity changed. A geodesist can report that uplift accelerated. A geochemist can report a change in fumarole composition. None of those specialists acting alone decides that 500,000 people should evacuate. The decision emerges from the whole system. This is also why the red zone should not be treated as a prediction map. It is a planning map. It identifies areas where the consequences of pyroclastic flows could be intolerable if an eruption occurred, so evacuation has to be completed before that hazard becomes active. The yellow zone addresses a different problem, especially significant ash accumulation. Different colors mean different hazards, and different hazards require different decisions. That brings us back to the phrase, far worse than Yellowstone. If worse means a larger magma chamber, a larger prehistoric eruption, or a guaranteed future catastrophe, the phrase fails. There is no honest scientific basis for turning Campi Flegrei into a simple winner in a supervolcano competition. But if the question is which system presents the more immediate combination of ongoing unrest and dense human exposure right now, Campi Flegrei deserves attention for reasons Yellowstone does not share. Yellowstone is currently at normal alert with background volcanic conditions. Campi Flegrei is under yellow alert with medium unrest. The Italian system has been uplifting since 2005, its earthquake activity has intensified, and a magnitude 4.7 shock in late July caused real disruption around Naples. Approximately 500,000 people live in its red zone, while more than 800,000 live in the surrounding yellow zone. That is not a prediction. It is the present risk landscape. The important question is what would have to change before that landscape became more dangerous. Scientists would look for a coherent escalation across multiple monitoring systems, not one isolated earthquake or one viral graph. Significant changes in deformation, seismicity, gas chemistry, and other observations would need to be evaluated together. Civil protection would then use those scientific assessments, along with vulnerability and operational considerations, to determine whether the alert level or operational phase should change. That process is deliberately slower and more disciplined than social media. It has to be. Moving hundreds of thousands of people is itself a massive operation. Waiting too long would be dangerous, but acting on every swarm as if an eruption had begun would also impose enormous costs and could destroy public trust. The system depends on scientists being willing to say two things at the same time. The unrest is real and the outcome remains uncertain. Campi Flegrei has spent decades forcing that tension into the open. The early 1980s crisis produced major uplift, thousands of earthquakes, and population displacement around Pozzuoli. Then the crisis subsided without an eruption. That history is a warning against assuming that severe unrest must end in eruption. It is also a warning against assuming that non-eruptive unrest is harmless. The modern crisis has now lasted since 2005. The surface has risen, the crust has been repeatedly stressed, earthquakes have become a recurring part of life for communities around the caldera. Authorities have strengthened monitoring, updated alert procedures, analyzed building vulnerability, and maintained evacuation planning. And still, there is no scientifically defensible eruption date. That is the central contradiction. Campi Flegrei is dangerous enough to justify a red zone for roughly 500,000 people, yet uncertain enough that no one can honestly tell those people when or even whether the next eruption will occur. This is why sensational predictions are not merely inaccurate. They can obscure the risk that already exists. The immediate hazard may be another shallow earthquake. It may be a swarm that produces building damage and transport disruption. It may be continued uplift with no dramatic event at all. Or the system may eventually move toward a more clearly magmatic crisis. Those are different pathways, and monitoring exists to distinguish them as evidence changes. For residents, the useful response is not to treat every tremor as a countdown. It is to know official civil protection information, understand whether a home or workplace lies in the red or yellow zone, follow instructions from local authorities, and recognize that evacuation decisions come from official alert, operational phases, not from rumors. For everyone watching from outside Italy, Campi Flegrei is a lesson in what volcanic danger actually looks like. Sometimes it looks like a mountain blowing apart. Sometimes it looks like a city where the pavement rises by centimeters, then more centimeters over years. It looks like instruments recording small changes that most people cannot feel. It looks like a magnitude 4.7 earthquake at shallow depth trains, stopping lights going out, inspections beginning, and then life restarting while the volcano remains beneath everything. Yellowstone is easier to imagine because its name already carries the mythology of a giant eruption. Campi Flegrei is harder because the danger is woven into normal life. A cafe can sit inside a caldera, a commuter rail line can cross a zone of uplift, an apartment block can stand inside an evacuation map. Hundreds of thousands of people can go to work each morning above a volcanic system that scientists are measuring hour after hour. That is the image to remember. Not a Hollywood super eruption. A living city on restless ground. And beneath that city, the measurements continue. There is one more boundary worth drawing. The phrase supervolcano is popular, but it can distort how people think about Campi Flegrei. The caldera has produced enormous eruptions, yet the most recent eruption in 1538 was much smaller. More than 70 eruptions over the past 15,000 years show a system capable of a wide range of behaviors. The next eruption, if one occurs, is not required to repeat the largest event in the geologic record. That is one reason emergency planning focuses on credible hazard scenarios instead of the single most cinematic possibility. The same logic applies to Yellowstone. Its geologic history includes huge eruptions, but its current USGS status is background. Campi Flegrei's current significance comes from the opposite combination, not a claim that its maximum eruption is larger, but the fact that measurable unrest is occurring beneath a dense urban area. So the strongest comparison is not about which volcano could make the bigger explosion. It is about which one is forcing more immediate decisions for people living nearby. That is a narrower claim, but it is also a more useful one. It turns the story away from a competition between ancient calderas and back toward the real problem, how a modern city lives with a volcanic system that can produce earthquakes, deformation, gas emissions, and in a future scenario that remains uncertain, an eruption. The science is not waiting for a dramatic finale, it is watching for change in the pattern.